Okay, so it's given us information to draw the demand curve on this question. And it says, your state is trying to determine how many vanity plates it will be able to sell at various prices. Regular license plates cost $20 and the state's per capita income is $30,000. A survey of other states with the same population generated the following data. So the same population, so that's all equal in all of these. And then the 30,000 income, if you look at these, it's the same population, but like C has a lower income. So you can't compare that directly with this state, because what it shows you on the chart is the price of vanity plates is over here and the quantity of vanity plates demanded is here. So those are the only two things that can change when doing this. So you have to keep everything else constant. That's ceteris paribus idea. So we have to look at states that have exactly the same price of regular plates and income, because that is those are two things that we're not graphing here, but they would change how the graph would behave if you change those things. So you have to use this, what we call this ceteris paribus idea. Okay, so the price of regular plates are $20 in state B and $30,000 income. So that's the same as the state. And this price of regular plates is $20 in state E and $30,000 income there. So those two things are the same. So we can use these two data points to plot our points. Okay, so it says use the point drawing line tool to plot 2 points on the demand curve for vanity plates. So we click on there, then we go $60, right? Because that's this axis. So we go up to $60. That's the price of vanity plates. And when vanity plates are $60, we're looking at data points B under the B column, right? So it's $60. We're going to get 6,000 vanity plates. And then E, again, remember E, we can use E because everything else is the same except for the stuff we're plotting. The other stuff, it remains the same for E and B. But for C, it's 25,000, so that's different. And for D, the price of the vanity plates is 35, so that's different. We can't use those in this particular plot. Okay, so now, but we can plot this one. So E is $40 and 16,000. So another point is $40 and 16,000. So what we're not done yet, we have to do two. Using the line drawing tool, connect the points to draw the demand curve. Label this line D plates. Remember that according to the ceteris paribus assumption, all other relevant variables must be held equal along the demand curve, right? So they're basically telling you that's why these 2 points are the only ones we have. Okay, so we'll draw the demand curve, and the demand curve is just the line from the 2 points, right? And then we add the label. That is our demand for vanity plates. Okay, so that should be correct. That's correct. And then it's going to ask us another question down here. It says, assume that the demand curve you have just drawn is linear, which it is. If your state set a price of $50 per vanity plate, you could expect to sell how many vanity plates? Well, we go to $50 price, and we go over here, and that looks like right at $11. So we'll check answer on that one. Oh, what we do here? Remember the units of the. Let's see. Maybe I read it wrong. Okay. Assume that the demand curve you have is linear. If your state set a price of $50 per vanity, you could expect to sell how many vanity plates? So $50, isn't that 11? That'd be right there. Oh, it's in thousands, so it tricked me, right? So yeah, we gotta be careful. It's not 11 plates, it's 11,000 plates. So it tricked me. So yeah. So now should be right. Yep. Okay, that's correct. All right. Hopefully that helps.